Alright, so 8.5a is the standard dealing with perfect squares. Instead of last year where we have to list out all the perfect squares, really this is relying more on our knowledge of the vocab, perfect square, square roots, squaring something. We need to understand the difference between each of those and then maybe apply that idea, exactly like we're seeing in that first example. It's not going to be so straightforward as last year where you're really just, the standard actually said list the perfect squares from 1 to 400. You just had to list out the first 20 perfect squares. Here we're going to be applying the idea of a perfect square. So this is an example of a perfect square. We have a square here. So we know that all the sides are the same. That and that have to be the same. I'm just going to call that x for now. Instead of trying to guess what number times itself would give us that, a really easy practical application of square roots is to work backwards to that number times itself. So we're going to take the square root of 81. That tells us that x, or the side, is 9. The question's not asking just for one side, though. It's asking for the perimeter. It's asking for all 4 sides added together. So it's really 4 times one of those sides, or 36. That is the perimeter of that square. The next problem is asking us to list out 3 perfect squares. It's a really easy way to find any perfect square. You just square a number. The next example is looking for us to find 3 perfect squares. This is really easy. You square any number and you got a perfect square. Let's square the number 50. That's 2,500. That's a perfect square. I know that because 50 times 50 equals that number. It's some number times itself. Let's do something easier. 4 times 4. That would give us 16. Let's do 16 squared. That's 256. Those are 3 perfect squares. I know that because it's a whole number times itself. And on these, I just want to check to see if they are perfect squares. Really simple way to do that is just take the square root of that number. If you get a whole number back, that means that that's a perfect square. If you don't get a decimal, it's a perfect square. So square root of 1 is just 1. That means that's 1 times 1. That's a perfect square. Square root of 2 is about 1.41. That is not a perfect square. Anytime you get a decimal, it's not a perfect square. Square root of 16 is 4. That's 4 times 4. That one's good. Square root of a negative number, square root of negative 16, is going to give you an error in the calculator. It's because there is no number times itself to give us negative 16. Negative 4 times negative 4 would give us a positive 16. 4 times 4 would also give us a positive 16. We can't use negative 4 and positive 4 because those are not the exact same number. Okay? That is actually why we have the real number system. That's why we call it the real number system. The square root of a negative is actually an imaginary number. Either way, don't worry so much about that. Square root of a negative is not a perfect square. Square root of 36 is just 6, so that's 6 times 6. That is a perfect square. Square root of 300 is 17 point something, doesn't really matter. That is not a perfect square because it's a decimal. This is going to give us the number 121. I know if I work backwards, square root of that, it's just going to give me this number again. It's going to give me 11, so that's a perfect square. I know 122 is not going to work because that's going to be 11 point something, so that's not a perfect square. The square root of 121 is really the number 11. We're not looking at 121, you're looking at the number 11 there. You want to decide whether 11 is a perfect square. 11 can't be because it's prime, so no number times itself is going to give us that. That is not a perfect square. Here we want to simplify this first and then decide. So we have negative 16 times negative 16. That would give us 256. And like we said right here, that's a perfect square. The square root of 625 is 25. So we're not looking at 625, we're really looking at 25. Is that a perfect square? When we do the square root of that, we get the number 5. That means that is a perfect square. Last one, same thing, square root of 169, that would give us 13. That's another perfect square. This next one's asking us to fill in the blanks. The square root of 16 is a perfect square because. Alright, so this number is really the number 4. Alright, so this is a perfect square because 2 times 2 equals 4, and 2 is a whole number. we have a whole number times itself to give us that number. That means that has to be a perfect square. Again, we're not really talking about the number 16 here. We're talking about the number 4 because it's the square root of 16. Right. Blank is the square root of 400 because, well, the square root of 400 is 20. And that's really just simply because 20 times 20 is 400. You can't do the square roots of negatives because no number times itself is negative. The square root of a perfect square is always a whole number. It's never going to be a decimal.